Hello everyone! Welcome back to another amazing video where we do some science stuff. Now you must be wondering, we're in the explosion lab today. Isn't that exciting? We've got our safety precautions on. We're just gonna get our helmet here because we're gonna be dealing with some dangerous stuff today. Now, if we look over here, today the main topic is going to be endothermic versus exothermic reactions. What's the difference? You must be wondering, what is the difference between an exothermic and an endothermic? Well, if we take a look here, I can give you the perfect definition. An endothermic reaction, right? Okay, let's read here. A chemical reaction that releases heat is called an exothermic reaction. When you burn an object in the presence of oxygen, energy that forms of heat is given off. Heat is also emitted when your body metabolizes food. A chemical reaction that absorbs heat not releases, absorbs heat is an endothermic reaction. If you observe the chemical reactions in Inquiry, activity B6, you notice that the temperature in the baking soda and vinegar reaction drop during and just after the reaction. So, chemical cold packs found in first aid kits are another example of endothermic. So, you've got your ice pack here. You've got your good old ice pack. Let's just observe actually, let's go ahead and observe endothermic, not exothermic. We'll get to the explosion lab later. This one here. Bob, didn't I tell you to clean this up? Bob's just a really person, everyone. You cleaned it up and he didn't. Oh, look at that. I punched a hole through the wall. Anyways, let's go ahead and let's repair our wall. Actually, you know what? Let's just repair our wall here. Now that our wall's repaired, we don't have to worry about anything else. Okay, I was wondering. You were going to show us an endothermic reaction, right? So if we take ice. No, not just ice. Not just ice. Take ice. This is our ice pack. Let's just pretend this is our ice pack, right? So you've got a boo-boo on your leg. You go to the good old office, and you've got a boo-boo on your leg. You go over there, and the lady at the front desk, she gives you an ice pack. She tells you read the instructions. It tells you to crack it. So you go ahead, you crack it. Do a bunch of stuff. You just do this, crack it, give it a little crack, and then it starts getting cold. What's this? That was an endothermic reaction. Another thing that we could do as an endothermic reaction is actually, you know what, that's really all I have. It's basically just crack an ice pack. One of those crackable ice packs. Yeah, see? You crack one of these and whew, it gets cold. Make your boo-boo freeze right up. Okay, anyways. Now that was a quick definition. Let me tell you. These videos are getting shorter every time you watch it, because we're trying to fit as much stuff as we can in a couple minutes. Let's just put on our safety gear again. Let's go to the explosion lab. You must be wondering, why are we going to the explosion lab? This must be something dangerous. Oh, trust me, it is real dangerous. If we don't go ahead, and if we do this anywhere else, it could risk our lab. Our lab could... Now, if we just take all this glass out, and, we have a glass in our hand so we can repair it after. But we see here, and you must be wondering, what do you have this here? Well, we're just gonna go ahead and grab, what's something that combusts in air, you must wonder? Well, for example, as we actually already know, sodium actually can combust in air perfectly. And here we can't really put it in the air and it'll combust, but in its form it'll bust up in air, and But we're gonna use something else for this, so we're gonna use this, okay? So you got this. Your sodium. It's not gonna make this, but let's say it's your sodium and black crap, right? And we take just some simple lever. We take some redstone. We take a redstone repeater, and we go ahead and we go here. We put it here. We go boom, boom, boom. Put the ticks up, so it takes a while to get there, and then we put the redstone at the end. Now, if you're wondering, that's only one TNT. You're right. It's only one TNT. How about we do all of them to make it more satisfying? So we're gonna expose it to air. For say I opened up a vent here, right? For say one of these things are vents, okay? And this thing reacts to air. So this is an air sealed tight container. But as soon as I press the button, the vent swings open and the top pops off, okay? We're gonna watch this now. We gotta cover up back up on safety. Got everything we need. And we click it. Oh! Seems TNT's not working. Now, just in case it was a false fuse, we're gonna just turn it off real quick. Okay. None of it went. Good. Now, if something like this ever does this, and it goes off like that, never go in and try to fix it immediately, as it could be a false fuse. You never know. Something could be on the edge of blowing up, but never did. Anyways, we're just gonna link it all on top. That was a failure of a science experiment, but now we're gonna, now the vent swings open, and the pop tops off. Just like that. Woo! And just like that, as we saw here, nothing's left. Now, you might want to watch just the scene a little. Maybe some sharp objects landed somewhere. I don't know, maybe glass. Who knows? But anyways, we're going to close this up. See what you just witnessed there? Was an exothermic reaction. We took air, and we used air to our advantage. So, it's going to go here. And that's really it for this science. See you guys in the next video. Have a nice day.